Why do we need powergui block? And when to use this powergui block? So now let's check this out. So guys, here we have the block of the day. The block is powergui. So first of all, we'll start with the name of this block. The name of this block itself suggests what and why it is used for. The name is powergui. GUI means graphical user interface. So whenever you are dealing with simulation, whenever you are dealing with graphical user interface, at that time you require this block. Don't worry, we are going to explore when and where. And to explain you where exactly this powergui block is used, let me explore this library. So in library, first we'll go to simcaps. In simcaps, we'll go to power system. In power system, we go to this specialized technology. And in specialized technology, we'll go to fundamental blocks. So just expand this fundamental blocks. So now here the where part comes. So in your simulation, whenever you are going to use parts from any of this section, then you must use this powergui block. And that is why this powergui block is located over here. That means in all of these sections, whenever you want to use any of the block, you must use powergui block in your simulation. Blocks like different electrical sources, different electrical elements, interface element, machines, measurement units, power electronics devices. Whenever any of this device you are going to use in your simulation, you must use this powergui block, right? Let me show you what happens when you use this block and when you do not use this block. So let us switch to my previous simulation, which I have explained in my previous video, three-phase inverter. So here in this simulation, in this corner, I have used this powergui block. So what I'll do, I'll run the simulation. Okay. It's done. And now let's see the result. Okay, so we have the results, right? That means simulation has worked. Now let me remove this powergui block. Done. The powergui block is not available in this simulation. And now let's run. Oh my God. There are varieties of errors occurs, right? So this happens when you do not use powergui block in your simulation, right? So I think first thing is clear to all of you that where should we use this powergui block? Whenever we require any of the component from this section of the Simulink library, then we must use powergui block. And now the second thing comes, but why we should use this powergui block? So let us understand that thing. Here what you can see, we have different switches, source, load, scope, and varieties of things included in this simulation. But now let us understand how exactly the MATLAB functions. The root of MATLAB is matrix. MATLAB stores each and every data in matrix format, and that I have explained in detail in my first video of introduction to MATLAB. If you are interested in learning that, then this is the video. You can check out this thing later on. So the fundamental of this MATLAB is it's storing all the data in matrix format. But here we are doing everything in GUI format. It is graphical user interface. It's a resistor, right? It's a symbolic representation, or ultimately it's a graphical user interface. But what is happening in backhand? In backhand, each and every component is made up through equations, and you all are aware of this. So each of this block in this simulation is constructed using equations. So how MATLAB deals with this graphical user interface and these equations? There this graphical user interface block comes in picture. So what exactly this block does? This block actually stores the equivalent Simulink circuit that we have prepared in this simulation and stores all the state space equation of that model, and when we run, it solves all the equation in backhand and then give the result to the scope, and then we can visualize those results. In other words, it simply stores equivalent circuit of prepared Simulink model in equation form. Right, so make it clear in your mind that the role of this powergui block is to store all this simulation in equation form, does all the process and then give it a visual result to us. So this is the role of this GUI block in our simulation. Now let us open this GUI block. When you open it, it has three varieties of solver. Right now it is continuous. You can see it is not enabled right now. I cannot make any change in this. If you want to enable it, what you are required to do, go to simulation, model configuration parameters, and from here I have randomly selecting any of this, right? So once I have selected any of the solver, now open it. So now here you can see the simulation type is enable. There are three types: continuous, discrete and phasor. If you select discrete, then you need to give a specific sampling time, right? This is the time on the basis of what you are discretizing the signal and do the required process. And in the third one, phasor, you are required to give the frequency. We'll make it continuous because I want it to be continuous. Here we have varieties of tools. If you want me to explain all of these things, then write that thing in comment and I'll make a separate video for this because it requires a long time to explain all these things. You can even make load flow settings over here, right? So that can be also managed from this section. And now the last one is preferences. So these are the different preferences for your simulation. Display circuit, differential equation. So these are the different settings and preferences that you can adjust it from